Happy afternoon, students. Welcome back to the biological session. We continue with the previous chapter, that is neural control and coordination. I hope you all safe and sound at home. So, time is now 2 p.m. and we'll start with the biological, that is biology session, neural control and coordination. Before we begin with this chapter, right, let us have a quick recap of what all the things that we discussed in the last week, in the last Saturday that we discussed about the central nervous system, where we discussed about the neural system and neural cells, what are the types of cells which present in the nervous tissue. And we discussed about the classification of the central nervous system, that is the neural system itself, where we classified the neural system into peripheral nervous system, autonomous nervous system, central nervous system. Under the central nervous system, there's a broad classification, the subgroup that we call it as brain and the spinal cord. We began with the spinal cord and the brain. Under brain, that is forebrain, midbrain, and hindbrain. That is prosencephalon, mesencephalon, rhombencephalon. Under each category, that is prosencephalon, mesencephalon, and rhombencephalon, we categorize like cerebrum, cerebellum, pons varioli, medulla oblongata, and we discussed about the other subgroups and the classification, and especially we discussed about the limbic system, their hippocampus, amygdala, and these are the other properties and functions, and what are the areas like the performing a neural control and coordination lobes that we discussed, the temporal lobe, parietal lobe, occipital lobe, right? So this is what actually we so far we discussed about this particular chapter in the last class. So now we'll continue with the same chapter, and also we're done with the spinal cord. So let us have a quick recap of what are the things like certain images that I couldn't show in the last week. So let us have the recap of those content that we discussed in the last week. So in this case, you could see the cerebellum part. So as far as cerebellum is concerned, this image shows the cerebellum, the view of the cerebellum, where you could see this part only we call it as cerebellum. This area we call it as a cerebellum. The cerebellum, and here you could see the pons, medulla oblongata, and the pons region. So this part, the cerebellum anterior lobe, and you have the cerebral cortex. And I told you it's a tree of life that we discussed. The tree of life can be otherwise called as arborvitae. So this is called as tree of life. So, and I told you like what are the main functions which performed by this medulla oblongata along with the pons varioli, right? And this is the posterior lobe, and here you could see the choroid plexus. This also I hope you remind I talking about the fourth ventricle. I talk about the choroid plexus as the brain. The human brain consists of four ventricles, right? We discussed about the four ventricles, and I hope you remember I specifically mentioned the two ampullas of fourth ventricle. I hope you can recollect all the things that we discussed in the last week. So choroid plexus of the fourth ventricle, and here you could see the flocculonodular lobe. The flocculonodular lobe which is present in cerebellum, and this part is medulla oblongata. And you could see the cerebral peduncles. They are superior peduncle, middle peduncle, and the inferior peduncle. So this image represents the structure of cerebellum. So this we discussed the last week itself. This is like for image that I would like to show. And this you could see the brain, that the posterior part of the sheep actually. This is the posterior part of the sheep. In this case, you could see this is the cerebrum part, okay? And this is cerebellum. As far as sheep is concerned, not the human, this is for sheep. So cerebellum, and this is medulla. Here you could see the medulla oblongata. This is medulla oblongata. And here you could see, right, the small region. This gland is called a pineal gland. This gland is called as pineal gland. And we discussed about the main functions of the pineal gland. Can someone tell me what is the main function of the pineal gland? I was like, we usually call this pineal gland as a biological clock that is responsible for the sleep and awake cycle. Then here we have the corpora quadrigemina. So I told you like corpora quadrigemina. You could see like four chambers that you could see in corpora quadrigemina. That is two superior and the two inferior, and two for like vision and two for your auditory functions. So here this part you could see in the midbrain. In the midbrain you could see the corpora quadrigemina. This is the sheep's midbrain. It's for your reference, and this is your cerebellum. It's for a cerebellum. Coming to the limbic system. This also we discussed. So as far limbic system is concerned, you could see the hippocampus. See, this part is called as hippocampus. We discussed everything in the last Saturday, last week itself. This is just a recap for you. So hippocampus, and here we discussed about amygdala. This is amygdala, and you could see the hypothalamus. This is olfactory lobe, and this is the frontal lobe, and in the middle central part you could see the thalamus. This is the thalamus region. So hippocampus, I told you, it's responsible for emotion, learning, and a memory. So learning, how you by hearting and storing those like informations in your brain. This is because of the hippocampus. Amygdala is for the eating, your drinking mechanism. As already told you, like it's for the sexual behavior. The strong sexual desires that you express sometimes is because of the amygdala. And hypothalamus monitors the blood levels of the glucose and the salt and blood pressure hormones. As I already told you, the hypothalamus, which is the masters of the master gland, this even controls the functions of the pituitary gland. And hypothalamus is responsible for producing two important hormones that we discussed as oxytocin, that is a birth hormone, and also we have the hormone called as vasopressin. So vasopressin is antidiuretic hormone. These details that we discussed already about the hypothalamus, that is oxytocin and vasopressin. So this combined structure that we call it as limbic system. When we talk about limbic system, so here you could see the thalamus, hypothalamus, and here you could see the amygdala. So these all hypothalamus, amygdala, and hippocampus. These are the main structure that you could see as far as limbic system is concerned. Okay, fine. Coming to the next part, the ventricles of the brain. As I already told you, there are four ventricles. There are four ventricles that you could see in a humans. Actually, there are four ventricles. Have the lateral ventricle. So this is the lateral ventricle. The lateral sides we have ventricle, lateral ventricle one, and interventricular foramen. This is interventricular foramen. This is the second one. This is one lateral ventricle, interventricle, and we have the third ventricle. So we have a third ventricle, and at last we have the fourth ventricle. So altogether we have the fourth ventricle. So four ventricles that you could see present in the brain. So lateral ventricle, interventricular foramen, third ventricle, and we have the fourth ventricle. I hope, do you remember I told about like foramen of like Meghandi that I told you, like there are two foramen that I reminded in the last week. So these two foramen which comes to the ampulla, this comes to the fourth ventricle. There are two ampular regions which comes under the fourth ventricle. This is for your reference. So mostly you will get a questions like how many ventricles are there in a brain, and sometimes you get a question from so how many the ampular regions like that you could see in case of fourth ventricle. These are the two possible questions that you can get usually from this ventricle part, right? So this is what we were discussing about in the last week, the ventricles that we are completing now. And also we discussed about the spinal cord. We're coming to the spinal cord. So as already told you, the spinal cord. So coming to the spinal cord, coming to the spinal cord. So spinal cord is a continuation of your medulla oblongata. I hope you remember the thing that we discussed, the length of the spinal cord, the weight of the spinal cord, how it actually emerges out of this medulla, continuation of the medulla oblongata, and how it grooves inside. And there is a neural canal. I hope you recollect the vertebrae. When we talking about like the atlas and axis bone, the vertebrae, there I discuss something about the central canal that is called neural canal. Inside the neural canal, you could see the spinal cord which grooves inside. So when we see the spinal cord structure, which arises from the cervical part, so which grooves inside, which goes deeper and deeper, and it goes deeper like this. So this is the part where you could see the cervical part, where the cervix region, the cervical part that you could see, the cervical region that you could see. Okay, the vertebrae, cervical vertebrae that you could see, and followed by thoracic region, followed by the thoracic, and then comes the lumbar region, and then you have the sacrum and coccygeal. So you have the sacral region, sacrum and coccygeal region. So through which all the parts of your like the backbone, this the vertebral column, you could see the spinal cord which deeply grooving inside. So for your reference, the length of the spinal cord. Can someone tell me what is the length of the spinal cord? This we discussed the last session itself. What is the length of the spinal cord? And what is the weight of the spinal cord? And how many segments are there in a spinal cord? So all these pieces of information, I hope I told in the last week itself. So or how many segments are there in a spinal cord? Okay, and it consists of two horns. That is, one is gray horn, other one is the white horn. So that is the gray matter and the white matter. So exactly it's a 35 grams and 40 to 45 centimeter, and segments are 31 in nature. Okay, so this we discussed already. And two horns, that is two horns is white on and the gray on that you could see 42 to 45 centimeters. So the length is 42 to 45 centimeters. So where it begins in the cervical vertebrae. So which part? That is your atlas bone. So the first vertebrae that is called as atlas. From there your spinal cord which started emerging and tapering at what? Tapering at the coccygeal region. So it tapers at the coccygeal region. This last region you could see the coccygeal, the tailbone that you could see, right? This is what actually it will be like tapering. So it will be tapering at last, and after this tapering is called as filiform. Actually, phylum terminal. This is called as phylum terminal. So where the spinal cord which goes for the goes to the tapering ends. This tapering end is called as phylum terminal. After this phylum terminal, you could see there's something like osteo, like appearance. The nerves, actually, these are the nerves, the spinal nerves that start emerging out of this. And this resembles like, horse tail. So the name that we gave for this horse tail, where you could see the emergence of the spinal nerves after this coccygeal region, this is called as cauda equina. This is called cauda equina is the name because it resembles like the horse tail. And what does it illustrates is the spinal nerves. These are all the spinal nerves which emerges after that, and it resembles like the kind of a horse tail appearance. So this is called as cauda equina. So cauda equina, and this coccygeal region is called as phylum terminal. So this region is called as phylum terminal, where it has got the tapering. The spinal cord has got the tapering end at the coccygeal region. This is called phylum terminal. After which you could see the emergence of the spinal nerves, and this gives the appearance of a horse tail. So we call it as cauda equina. So this we discussed about the spinal cord. Okay. So coming to the next part, that is the peripheral nervous system. So we're done with the central nervous system, where we discussed about the brain, that is forebrain, midbrain, as well as the hindbrain, and also we discussed about the spinal cord. Next, we're going to discuss about the other system, the peripheral nervous system and the autonomic nervous system. Coming to the other part, the peripheral nervous system. Peripheral nervous system. So coming to this part, the peripheral nervous system. So we have something called as spinal nerves here. So coming to the peripheral nervous system, simply we call it as PNS. PNS stands for peripheral nervous system. Under the peripheral nervous system, things that we're going to discuss is about the cranial nerves and the spinal nerves. We discussed about the nerves, cranial nerves and the spinal nerves. Okay. So often questions comes from this part, the cranial nerves actually. What is the formula for the cranial and what is the formula for the spinal nerves? So as far as spinal nerves, you're aware of it is actually, so C, that is cervical, thoracic, lumbar, then we have the sacrum and the coccygeal part. So the lumbar part is L and coccygeal. So coccygeal part, and we have the sacrum part that we have and the coccygeal part we have. Coming to the formula for the spinal nerves is 8, 12, 5, 5, 1. So here it's 8, 12, 5, 5, 1. So the question comes about the spinal nerves. What is the formula for the spinal nerves? Is C18, T12, L5 and S5, and we have a 1. So altogether this comes like this is cervical, the vertebrae, this thoracic, L stands for lumbar, and this is sacral, and that is C is a coccygeal part. So questions come from this part, especially the spinal nerves. What is the correct formula for the spinal nerve if they ask you? So then you should go with this type: C8, T12, L5, S5, and C1. Okay. Coming to the cranial nerves. This comes like what are factors? O, T, F, A, G, B, S, H. So this is what actually like O, T, F, A, G, B, S. Somehow you should remember the sequence. What are factors? O, T, F, A, G, B, S, H. Coming to this, like we have like O is 3, and T. When coming to the T, this T is actually 2 in number, 2, and all other things are 1, 1 each. So coming to the cranial nerves formula. If the question comes O, T, we'll discuss about what this O, T, F, A, G, B, S, H, all these things like denotes here. But you should recollect the formula for the spinal nerves and the cranial nerves, which we categorized under the peripheral nervous system. O, T, F, A, G, B, S, H. So O is 3, T is 2. So 3. So why? Because I arranged in this way because First start with 3, next with the 2, and all remaining things are 1 each. So what a fact wish O, T, F, A, G, B, S, H. Here C8, T12, L5, S5, and C1. This segment you need to understand and need to at least recollect the formula of the cranial and the spinal nerves. So from this area you can get a question. So for this, the cranial nerves. And coming to the cranial nerves, we have actually 12. Cranial nerves, we have 12. When we count together, we come to like how many cranial nerves are there? There are 12 cranial nerves. Spinal nerves, when you could see, spinal nerves, that you could see 31 pairs of spinal nerves. This type of questions also you could see actually. So here you could see 31 pairs, and here like cranial nerves you could see 12 in number. 12 in number. So this is C8 only. So as far as we're not talking about the vertebrae here, we're talking about the nerves. When we're talking about the nerves, it's 8 in number. So I'm not talking about the vertebrae. So section of vertebrae is 7. But when we're talking about the nerves, this comes 8. So cranial nerves are 12 in number. Spinal nerves that you could see 31 pairs are there. Okay, this is about. So coming to the cranial nerves, there are 3 types of nerves. What are the 3 types of nerves? Can someone tell me what are 3 types of sensory nerves, motor nerves, and the mixed nerves? We have sensory nerve, motor nerve, and we have a mixed nerve. We are talking about this only. So out of this, right? So it's a combination of 3 types of nerves, your cranial nerves. Some are sensory, some are motor nerves, and some are mixed nerves. So sensory nerves are 3 in number. Sensory, out of this 12, sensory nerves are 3 in number. Motor nerves are 5 in number. 5 in number, and mixed nerves are 4 in number. 4 in number. So 5, 6, 7, 8, 9, 10, 11, 12. So automatically this comes 12. This comes like 12 in number. So out of this, sometimes if this question is very specifically, they'll ask from this part, out of 12 cranial nerves, how many sensory nerves are there? So sensory nerves are 3. Motor nerves are 5. Mixer nerves are 4. So altogether we have the 12 nerves that you could see in case of cranial nerves. So what do you mean by the sensory nerves? Sensory nerves are nerves which send the signals from the sensory organ to the central nervous system. Motor nerves that you could see, it's from the central nervous system, it goes to the sensory organ. Mixer nerves is actually the combination of both that you could see. Combination of both that you could see. So here you could see sensory nerves. What are sensory nerves? It sends the signals from the sensory organs to the central nervous system. So this is what actually the polarity will be, the direction. And motor nerves are from the central nervous system. It goes back to the sense organs. Mixer nerves that you could see on both the directions it will be happening. So there will be like mixed combinations of both the types of nerves, right? So this comes like 3, 4, 5, 6, 7, 8, 9, 10, 11. So what are fact which OTFA? I check like what are fact which the nerves which comes like OTA. So here one more will come. A. I'm sorry for this. I skipped one is there. So this comes 12 actually. OTA. A will come. Okay. So I excluded this A here. This one OTA will come. So this again like auditory, the nerves will come here this part. So if again you include this one here, then this comes totally comes 12 in number. I think like Priyanka, I answered for your question. Suppose like this it was like count was like 11, but when you I skipped one A here. So 3, 2, 1, 1 remaining one. So 3, 5, 6, 7, 8, 9, 10, 11, and 12. So now automatically like total the 12 is coming. The cervical there are like 7 vertebrae, but when we coming for the nerves it is 18 number. So it's 18 number because it consists of 31 segments. Okay, so guys please include this A here as far as the formula is concerned. Like thanks Priyanka, thanks for reminding. So OTA. Here you need to include the additional one, then it comes 12 in number. So OTAFAGBSH. Okay. Mixed nerves where you could see both the functions, where you could see the central nervous system, from the central nervous system to sensory organs, and again you could see the vice versa conditions, central nervous system to sense organs. So both combination that you could see in case of mixed nerves, the mixed nerves that you could see. So you need to remember one this part. Sensory is 3, motor is 5, and mixed nerve is 4. Together we call it as 12 in number. So this is actually the cranial nerves. So coming to the spinal nerves. So here mentioned like the spinal nerves. When you come to the spinal nerves, I'm not talking about the vertebrae, I'm talking about the spinal nerves actually. So when we talk about the spinal nerve, you could see this is actually the 8 part, the cervical This is 8 that you could see. And thoracic nerves, like it starts from T1 to T12. This comes like 12 in number, and this comes like 8 in number. And for L1, L2, L3, L4 lumbar nerves, it comes like 5. Sacrum 1, 2, 3, 4, and 5. This is 5, and this is 1. Okay, and this is what I told you, like cauda equina. There you could see the spinal nerves which is emerging out, and this will resemble the form of or tail-like appearance So we'll discuss about the cranial nerves in a separate slide. So this image which represents about the spinal nerves, as well as peripheral nervous system, you need to remember two types of thing. One is cranial nerves, the other one is spinal nerves. And the formula, and coming to the formula, when you make the split up of this 12, sensory motor and the mixed nerves, this numbers that you should remember all the time. So from this area, you can get one possible question. Okay, for this only we're discussing about this. And coming to the next part, that is your peripheral nervous system. This is what we're talking about. Coming to the cranial nerves, we already discussed it's actually 12 in number. I hope you can recollect the formula. And coming to the spinal nerves, you could see the 31 pairs that we discussed. So the previous slide, I hope you remember. So this 12 pairs, and this is like 12 pairs, and this 31 pairs, and this image which represents the cranial nerves which consist of 12, and the spinal nerves which consist of 31. And for 12, I gave the divisions like spinal nerves and motor neurons, sensory neurons, and the mixed. So that classification that you should remember. This is for your peripheral nervous system. So under peripheral nervous system, we discussed about cranial and the spinal nerves. Coming to the next part, that is cranial nerves. Coming to the cranial nerves, we're done with this spinal nerves. Coming to the cranial nerve. One second. So coming to cranial, so spinal nerve and peripheral nervous system that we discussed. Okay. Next we move on to this. So we're done with the peripheral nervous system. We move to the next part, that is your autonomic nervous system. So when we move to the autonomic nervous system, before that, what is the main function of this cranial nerves and this peripheral nervous system? As far as peripheral nervous system is concerned, the main function that I'd like to highlight here is for the peripheral nervous system. The main functions of the peripheral nervous system is your smell, vision, movement. Actually, it's usually for your smell, vision. It's usually for your vision and your movement especially of your eyeball and movement of your rotation of your eyeball. So movement and rotation of your eyeball. Movement and rotation of your eyeball. Okay. So movement and rotation of your eyeball and the tongue movement and the facial expression. These also some of the main function. Tongue movement and facial expression. These are the combined effects of the spinal nerves and the cranial nerves that we've been discussing about. So coming to the next part, that is the autonomic nervous system. Coming to the autonomic nervous system, we have two types of nerves here. ANS. ANS stands for autonomic nervous system. That is two types of nerves, parasympathetic nerves, and we have a sympathetic nerves. When I differentiate the nerves of autonomic nervous system, parasympathetic nerves and the sympathetic nerves. Sympathetic nerves is usually used for the emergency purpose. These nerves, like when it be activated, when in case of emergency. Parasympathetic nerves usually get activated when it is in a resting condition. So usually in the resting condition, this parasympathetic nerves gets activated. So that's the reason that parasympathetic nerves actually rest and digest, and sympathetic nerves actually, which usually we call it as a fight or a flight, because it used only in the activated during the emergency condition. So what if you make a difference between the cranial nerves and the spinal nerves of the parasympathetic and the sympathetic nerves under the autonomic nervous system? See, the parasympathetic nerve, it can constrict the pupil. If this is constricting the pupil, this is dilating the pupil. So this stimulates the saliva. This is inhibiting the salival secretion. This slows down the heartbeat. Here it increases the heartbeat. So that's the reason it's called as emergency nerves. And it constricts the airways. It's relaxing the airways and stimulate the activity of your stomach, like producing gastric secretion. Here it's like inhibiting the activity of the stomach. Here you can inhibit the release of glucose and it stimulates the gallbladder. It stimulates the release of glucose and inhibit the gallbladder. So you could see the vice versa condition which you could see between the parasympathetic and the sympathetic nerves. And you could see stimulates the activity of intestines and inhibit the activity of the intestines. And here it will secrete. And this important part, why we call it as emergency nerve, because it secretes epinephrine or norepinephrine. Epinephrine or norepinephrine. This we discussed already, epinephrine or norepinephrine, when we discussed about the emergency hormone, the endocrine system. The last chapter we discussed about this function of epinephrine. So who is secreting this? Sympathetic nerves is secreting epinephrine and norepinephrine, and it relaxes the bladder. It relaxes the bladder and promote ejaculation and the vaginal contraction. Sympathetic nerves. This one, if it relaxing, this one is the contracting the bladder and promote the erection of the genitals. So erection of the genitals, of course, like because of what? Because of the parasympathetic nerves. So this difference which tells you, like, between the sympathetic and the parasympathetic nerves. And one more thing that you could see, the other differences, like, so this is actually coming from the main area, the cranial nerves, and then it's going to, like, several branches. But here, so you could see some branches are coming, these branches are getting united, and it's going to the particular organ. By a particular organ it reaches. So this makes a difference again, like sympathetic and the parasympathetic nervous system. Sympathetic is for the emergency purpose, and parasympathetic is for resting condition. And when it coming to the ganglion sites, and when you're talking about the branches, where you could see coming from the main node, and from the main node it takes the branches and it gets separated. But in case sympathetic nerves, already the branches which emerges out of this nerves, and then it fused together, and then the fused part will go to the particular organ. So this also which makes the difference between the sympathetic and parasympathetic, how the ganglions which emerges out, and this ganglions is nothing but the fusion of the nerve cords, and from the nerve cords how the signals which will be passing outside. So here you could see the branches emerges from the nerves and get fused together and go to the particular organ. Here what happens, like, here the fusion of the nerves which comes, and then it's getting branched. This also which makes the difference between the parasympathetic and the sympathetic nerves. So this is for your reference. Next we move on to the next part. The next is you could see anatomical differences. Anatomical differences in the sympathetic and the parasympathetic divisions. We discussed already about the difference between the sympathetic and parasympathetic, and this slide which tells you, like, what is the difference. Come to the different regions of the central nervous system. So this is the main difference, sympathetic and parasympathetic. This arises from the thoracolumnar region, and this is from the craniosacral region. So coming to the, like, parasympathetic region, this parasympathetic which arises from the cranial part. This is from the cranial part actually. But when it comes to the parasympathetic is comes which emerges from the cranial part, and sympathetic which comes from the thorax region. So this arises from the thorax. So this from the thorax region, and this arises from the cranial region. So this makes the anatomical difference between the parasympathetic. So which is something, the question comes like, which types of nerves, the parasympathetic nerves which arise from which area. So you could see it's the parasympathetic is from the cranial part, and sympathetic nerves which arise from the thoracic region. This also which makes anatomical difference that you can enlist between sympathetic and parasympathetic. Locations of the ganglia. So as far as sympathetic is concerned, the location is very close to the spinal cord. But here it is at parasympathetic, it's close to the target organ. This makes a difference again between the sympathetic and parasympathetic. Parasympathetic, these nerves are close to the target organs, maybe a liver, a spleen, or kidney, whichever the organ that you're talking about. But parasympathetic are very close to the target organ. But sympathetic nerves that you could see, sympathetic nerves are close to the spinal cord. So if this type of question, you need to be very clear. The nerves which are very close to the spinal cord is sympathetic, and the nerves which are very close to the target organs, this is actually parasympathetic. This makes the second anatomical difference. And sympathetic, third difference. So this is the first difference, and this is your second anatomical difference. And third difference, when you take between the sympathetic and the parasympathetic, sympathetic is actually long. So from here it need to travel a long area. So it's a long, and parasympathetic is comparatively, see here it is only this much actually. It is very short. Parasympathetic is short, and sympathetic nerves are long. So based on this part, from this sympathetic and parasympathetic, you can get 1 point of time, you can get on question. So parasympathetic is long, and sympathetic is long, and parasympathetic is short in nature. And post ganglion branching, here it's like, we have lost so that multiple organs can be mobilized in once. In parasympathetic, you'll be having branches less actually. You could see in parasympathetic, so the branches are very less, so very few branches you could see. But here you could see you have more branches in case of sympathetic. Sympathetic, we have a more branches you could see in case of sympathetic. Less amount of branches, number of branches that you could see in case of parasympathetic. So this makes the fourth difference. Anatomically, you want to differentiate the sympathetic and parasympathetic nerves under the autonomous nervous system. These are the four differences that can make. So the location. So sympathetic is for the thorax region, parasympathetic from the cranial region. Second difference is sympathetic is very close to the spinal cord. Parasympathetic is very close to the target organs. Then the third difference is sympathetic is long and parasympathetic is short. Fourth difference where the sympathetic where you could see more of branches and parasympathetic very little amount of the branches that you could see. So this makes the overall difference between the sympathetic and parasympathetic under autonomous nervous system. Okay, coming next we discuss about the synapse. Coming to the synapse, this we have studied in the textbook itself. So it's a basic understanding that you might have studied already about the synapse. Coming to the synapse here, the synapse is nothing but what? It's a proximity. Proximity between, can you tell me the region where the synapse, what is actually this region? This is actually the axon region. This is the axon region and this one is the dendrite region. So this is the axon of a neuron actually. So this is one neuron, this other neuron. So this proximity, a close proximity between your axon. So target organs means which are the organs, because nerves are some way it's going to connect it with your organs, your internal organs. So this is spinal cord. From the spinal cord, it's taking the cranial nerves, the spinal nerves, and through the parasympathetic and sympathetic nerves, and it's supposed to transfer the signals or impulses to the target organs, maybe a liver or kidney, all the visceral organs, right? So how these are the organs. These are organs where the generated impulse is reaching, right? So these organs are called as target organs. Okay. To take any visceral organs, your liver, kidney, spleen, any internal organs that you take, so these are the target organs. So the synapses actually which transfer between your axon terminal and your dendrite. So this is one neuron and this is the other neuron. So how the transmitters are getting transferred, the synapse is getting transferred. This is the axon region of the dendrite and this is the axon region of the neuron and this is the dendrite region of the neuron. Okay, so proximity area between the axon end bulb and the neuron dendrite of the other. So synapses can be classified into two types actually. What are the two types of synapses? We have the chemical synapse. We have chemical synapse and we have electrical synapse. We have two types of synapses which is quite common. But practically speaking, chemical synapses are greatly functioning in your body. Usually we people have human beings, we have only the chemical synapses, but neurotransmitters are like very rare and very, very rare conditions only. The neurotransmitters like Superman, like this type of conditions where you could see the persons having like supernatural acquiring natures. These people have some things like this electrical synapses. So we're going to discuss about the difference between the chemical synapses and the other thing, that is electrical synapses. Coming to the chemical synapse, based on the cleft that you could see, the gap between your axon and the dendrite, right? Here the difference that you could see in case of chemical neurotransmitters, here it's like 10 to 20 nanometer. In case of chemical, this distance is actually cleft is 10 to 20 nanometer. This is for chemical. This is for chemical synapses. In chemical synapses, the gap between the synaptic cleft, you could see the synaptic cleft, right? The synaptic cleft, the gap is comparatively more. So where you could see chemical is 10 to 20 nanometer. In between where you could see the neurotransmitters, the acetylcholine, because acetylcholine, that is from the adrenaline where it's getting produced. So there the cleft gap is 10 to 20 nanometer in case of chemical. But in case of electrical is 0.2 nanometer. When come to the electric, it is very less. You see 0.2 nanometer in case of electrical synapses. It's very the gap is very, very less. See, just 0.2 nanometers. So if it's just the gap is very less, it doesn't require any chemical substance like acetylcholine to get transferred from from this axon to the dendrite. So since the gap is very less, the impulses also will be like very faster. It will be generated. It will be get transferred transferred. So there you need not require in electrical synapses. There the neurotransmitters, there the acetylcholine, this chemical substance is not required. The reason why, because the cleft, the gap between your axon and the dendrite of the neuron is very less. It's only like 0.2 nanometer. This in case of electrical synapse. But in terms of like in normal cases, we human beings, like we have this mechanism based like chemical synapses where the gap, because the gap between these two is more like 10 to 20 nanometer, it requires some chemical substances. What is the chemical substance here? The neurotransmitters, we call it as acetylcholine. So this acetylcholine I need to transfer. So for that it requires some the receptors, the neurotransmitter, the receptors should carry that particular the chemical substances from axon to the neuron. So because the gap is 10 to 20 nanometer. So this comes the difference between the chemical and the electrical thing actually. So what is happening, like the cleft, what is the gap of the cleft? Sometimes the question comes, what is the gap of the cleft is 10 to 20 nanometer. What is actually the gap of the chemical synapse? That is also 10 to 20 nanometer, the same. But when it comes to the electrical is 0.2 nanometer, but it's practically it's not quite common in human beings. Only in if you are like supernatural places, only you could see this type of electrical synapses gets generated. So when we talk about the structure of the synapse, you could see the axon region, axon terminal. You could see the vesicles. This vesicles we call it as synaptic vesicle. This synaptic vesicles is getting formed inside the axon, and this consists of the neurotransmitter. So this neurotransmitters like get fused with the membrane, and this membrane of this axon, which has got the voltage gated calcium ion channels, and because of this calcium ion channels, like these neurotransmitters can be eliminated out. So once it get eliminated, then what happens? This will be received. This is actually neurotransmitters. We call it as acetylcholine. So acetylcholine. This acetylcholine, which receives the impulse actually, which receives the impulse from this particular axon of the neuron to the dendrite part of another neuron. So this will be receiving, and here you could see the receptors. You could see the specific the receptors that you could see. This neuroreceptors which receives the signals, that is the impulses which is getting generated, that is by means of acetylcholine, the neurotransmitter. This is getting received, and then what happens? The impulse will start generating to this particular dendrite. So what happens in this case, where you could see like in all the cases, like it's plus here inside minus. Once the neurotransmitter is getting transferred inside, then what happens? The plus will become minus, and here inside, it will become plus. So here this is where the mechanism, we call it a sodium potassium pump mechanism occurs. So we're going to discuss the next slide. So once the axon is getting start producing the acetylcholine. So what this acetylcholine will do, this acetylcholine will start spreading the impulse. So the impulse start generated. So the mechanism start appearing. So once what happens, like the neurotransmitters which gain insight through the receptors, this collects the neurotransmitters acetylcholine. Now this exchange the ions, which ions that is getting exchanged? Your sodium and potassium ions are getting exchanged. So usually, like in the normal condition, resting potential, when you see your dendrites, you could see the neural surface, outside it is a positive and inside it's because it's a negative, because of sodium and potassium. Outside is more of sodium and inside you could see potassium. Once the impulse started generated, so what will happen? The negative will become positive will become negative. It means what happens? The sodium is coming inside and potassium started going outside. So from the resting potential, now the impulses started generating. So the resting potential is getting conducted to the action potential. So this we call it as a mechanism of like how the impulses started happening. That we're going to discuss in the next slide. So I hope you're clear with the synapse. This is what actually happening in one particular. This is for the chemical synapse. I'm not talking about the electrical synapse, because electrical synapse, it doesn't have this type of gap, and this mechanisms like neurotransmitters, acetylcholine will not produce in case of electrical synapse. Acetylcholine, this produced only in case of chemical synapse, where this received by the receptors of this dendrite and this transferred. Once this impulse getting conducted, then what happened? From the resting potential, this getting transferred to the action potential. So the next slide we discussed how this mechanism. So we discussed about the mechanism of nerve impulses. So I hope you're clear with this part. Fine. When come to the mechanism of conduction of nerve impulses. Coming to the mechanism of conduction of nerve impulse. Mechanism of conduction of nerve impulse. conducting nerve impulse. So I told you now, just in the last slide. So what is happening? This is the axon part I'm talking about. I hope you remember. This is the axon of the neuron, and this is the region I'm talking about, the dendrite part. So this is actually the dendrite part. So now what is happening? The acetylcholine is getting transferred. The acetylcholine from by means of this vesicles, the neurotransmitters, like it's producing acetylcholine. This acetylcholine is getting transferred from the axon part to the dendrite region of the neuron. So this diagrammatic representation, right, which tells you like what exactly the mechanism which is going to occur in case of the nerve impulses when the impulse is getting transferred. So what exactly is going to occur inside the dendrites that we could see in this case? So first is like generation of impulse. So the first stage is generation of impulse. The impulse has to be generated. This is the first stage. And coming to the second stage, conduction. Conduction should occur. So conduction of impulse. Conduction of impulse. Third stage is repolarization. Repolarization. And the fourth one is the resting phase. The resting phase. So these are the four stages that you could see in case of mechanism conducting a nerve impulse. First is generation of the nerve impulse. As I already told you, like the resting potential. So the generation of impulses, which usually occurs where? Usually occurs when the nerves are in the resting condition. So in the resting condition, resting phase. So what is actually the volts that you could see in the resting phase? The resting phase, the nerve fibers, you could see in -70 millivolts. Question comes like, no, what is the potential where you could see in the resting phase? The potential is like -70 millivolts. When it is like coming to the conduction, during conduction, what happens? This -75 is getting transferred to what? -55 is getting converted to -70 is converted to -55 millivolts. And after that, when it reaches the action potential, this -55 which gets transfigured to +45. So this +45 is for action potential. So you need to recollect these two values. What is the potential when the nerve fibers, when the nerves, that you could see in the resting condition, so where the impulses are not being transferred, it's going to just begin at the resting condition where outside you could see all the positives. So can you see in this part, in this image, you could see outside full of all positives, all positive you could see. Here you could see outside, but here inside you could see all are negative organic ions, that is potassium. So when you could see the resting condition where you could see outside is full of the sodium ions, which gives a positivity, and here you could see inside is full of negativity. So this is a resting condition where the polarized membrane you could see. In this case, here the volt is -70 millivolts, -70 millivolts. So what is happening? I told you in the last slide, in the synapses, when synapses getting generated, then what happens? When the acetylcholine comes, when the impulses started generated from one segment to the other segment, then definitely what will happen from the resting potential, substantially it takes to the next stage called as action potential. Then what is happening inside in the neurons? What's happening? There is exchange of ions is taking place where the sodium from outside is going inside, and potassium which is present inside is going outside. Vice versa condition. It's due to by means of sodium potassium pump. We have a channels called as the gateway. We have a gateway, and this gateway is closed and open only when there is a condition where the impulse is getting generated, where it goes to the polarized, repolarization, depolarization. This is based on the mechanism of movement of the sodium and potassium, which gives the positivity and negativity, right? So we'll do with this. So first is -70 millivolts. In this case, what happens? Like you see, this area you take where the outside it was positive. Now the sodium is going inside through the gateway. This going inside. So inside is getting positive. When it's going inside the positivity, where this is like -55. When it goes inside, like inside, where you could see the concentration of the sodium started increasing. Then what happened then? Then the potassium, by means of potassium pump, what will happen? The potassium which will be forced to go outside. So outside there will be a negativity. It means this is the condition where the sodium is going inside and potassium is sodium is coming inside and potassium is going outside. This condition where it reaching the action potential, action potential reach the condition of +45 millivolts, +45 millivolts. So the action potential has been generated. Then from one particular segment, it move on to the next segment. From here, it will go into the next segment. Then it will keep on moving to the next segment. This is what actually impulse which will keep on, spreading the impulses to the one segment to the other segment throughout the neuron. So this is what actually we call occur in the 4 stages, where the generation of impulse and conduction of the impulse, repolarization, and finally it come back to the normal condition, the polarized state in the resting phase itself. So these 4 stages that you could see in case of the mechanism of conduction of the nerve impulses. In this area, you should remember about the potassium and magnesium, so potassium and sodium. These two ions, how this is getting transferred by means of sodium potassium pump are the pathway or the gateways, the channel that you could see through which only is getting transferred. One thing. And second thing in the resting potential, what is actually the volt that you could see, the 70 volts. When you come to the action potential, this is action potential. When it reaches action potential, it is like plus 45. When it is in resting potential, the volts is like minus 70. So this area that you could see, remember. Okay. So this is about the mechanism on conduction of the nerve impulses. And coming to the resting phase, the last stage, which requires ATP. Definitely it requires ATP because it has to like switch over to the old form itself. For that, it requires ATP. Through that, what will happen? Because the nerves should go back to the normal condition, then it requires ATP, the energy it requires. Then at this point, what will happen? Sodium will move on to the normal condition outside, and then potassium will come back to its own normal phase that is inside. So for that, it requires energy by means of adenosine triphosphate. Transport Na outwards and potassium into the cell. Yeah, because already like in a normal condition, potassium is present inside. When this action potential reach, when impulse start about to generate, then potassium start going out and sodium it start coming inside. When the potassium goes outside, when excess of sodium start coming inside. So first time what happens, only the sodium pump opens. Second time what happens, like potassium pump opens, and the third time only when it going for the last condition, the resting the resting phase, both the sodium and potassium pumps started functioning together. Almost the resting condition. Outside it is positive, this is because of sodium. Inside it is negative, this is because of potassium. During the transfer of impulses only, there is an exchange of these ions takes place. Yes, fibrinogen is for the clotting, blood clotting, and platelets also for the blood clotting. Then how they differ? So platelet is a common phenomenon. Platelets, in the platelets you could see the presence of blood clotting factor. It's a fibrinogen. Fibrinogen is a clotting factor, where the fibrinogen is a soluble, and this fibrinogen is getting converted to insoluble part called as fibrin. So fibrin and fibrinogen, these are the clotting factors. Where these all present? These all present in a, what do you say, like in the platelets. It's present in actually the platelets region. So don't get confused with the platelets and the fibrin. So this clotting mechanisms occur by means of platelets, but these factors are called as fibrinogen and the fibrin. Okay, so there's of course a difference between the platelets and fibrinogen. Whereas the fibrinogen is soluble or insoluble. It is soluble. This fibrinogen need to convert it to insoluble matrix structure is called as fibrin. Then only your blood will be clotted. So present, yes, fibrinogen is a clotting factor, as a protein. It's an insoluble protein which is present in a plasma. It's a soluble protein and it need to be converted to a insoluble matrix called as fibrin. I hope I cleared your doubt. Fine. So we're done with the mechanism. Next, we move on to the properties. When coming to the properties of the nerve fibers, there are a few properties like you see excitability. All or none rule. I hope we discussed about the all or none rule when we're discussing about like it takes entire impulses, all or none rule. So first is excitability. The second feature is all or none rule, and next one is like differential permeability. Differential permeability, where it is more permeable to potassium when it is in the resting condition, and conductivity and refractory. Okay, clear with this? So next we move on to the next part, that is sense organs. Before going to the sense organ, we discussed about the spinal cord, that is cross section that we'll see. When we discuss about the cross section of the spinal cord and the spinal, and this is a slide which tells you, like I forgot to show this slide. This slide, guys, listen. This are the 12 cranial nerves. We discussed about the spinal nerves, right? So this is your cranial nerves. What a fact wish that I told you, right? OTA, FA, right? These are all the OTA, FA, OT. I hope you remember. What a fact wish. GVSH. Okay. So what is an OTA, FA, You might have this particular doubt, and one of you asked which is the largest, the cranial nerves. Also, someone you asked the doubt. So I hope this segment which like the slide can give you the answer. So I clearly mentioned the 12 cranial nerves. So can someone tell me out of this 12 cranial nerves which is the largest nerve? So I'll start with this 12 cranial nerves. What of Agwish? I told you O, T, A, F, A, G, B, S, H, right? So what is this? The O, T, F, A, G, B. These are actually the first letter of all these nerves only. I mentioned as O, T, A, F, A, G, B, C, B, S, H. I hope you can recollect the formula. So the formula that I gave in the beginning. Olfactory is for smell. Optic nerves is for the vision. Oculomotor is for the eye movement and the pupil reflex. Trigeminal, it's for the face sensation. Sometimes when you someone like slap on your cheeks or face, you sense some things. When you have like the toothache, you have a pain here also, right? So you can how you can sense this type of right. This is trigeminal. So this is the larger nerves. Trigeminal nerves is the largest nerve. So this is the answer for your question. You have someone asked beginning, which is the largest cranial nerve? Trigeminal nerve. That is actually for a facial expression, right? Trigeminal is the largest nerve, and facial is a facial movement and the taste. Facial movement and the taste, and glossopharyngeal region. Glossopharyngeal region. This is a thorax sensation, taste, and swallowing. I hope if this image is not clear, I mean, I'll be sending to you. So if you require these images, I'll send it for you. So if this font size is not clear, so no issues for you. So I'll be sending it across to you. So now we listen to the class. Glossopharyngeal, it's for thorax sensation. When you like swallowing certain things, when you like something the disturbance that you could see in the glottis part where you could see you could not swallow things properly, right? This thorax sensation and swallowing. Accessory is for the neck movement. This area where you could see the neck movement. This accessory nerves which are responsible. Hypoglossal, it's a movement and sensation of the abdominal organs. For all the abdominal organs, these nerves are important. Vagus nerves are the sensation of the abdominal. Sometimes you feel like abdominal organs, sometimes the pain, the stomach ache, all these things which comes, right? This is because of vagus. Vestibulocochlear region. This is for your hearing, for your ear. Vestibulocochlear region, and your abducens. Abducens is for your eye movement. There's a difference between the eye movement and the eye rotation. There are two different things are happening. Like one is eye movement, other is the eye rotation. So this is by means of abducens. Eye movement, where you could see abducens, where you could see like trochlear movement is also for eye movement, and optic is for your vision. So out of you could see I given the classifications, the units of what this otafagwish stands for. I hope you can recollect like 3 2 1 1 1 1 1. So this I gave the 12 like the 12 cranial nerves. I gave the formula, the 12 cranial nerves. These 12 cranial nerves, this is all the expansion of otafagwish. So this may be shuffled all over, but for your understanding, 3 to all remaining 1. So you can easily recollect it. So for that only I make it in this way. Otafagwish, OTA, FA, GB, SH. So we count together, it comes like 12 in number. And this image which tells you like what are the 12 cranial nerves that you could see. Okay. So we're done with the cranial nerves and spinal nerves. Next, we move on to the spinal cord part. So spinal cord is concerned, this is the reflex arc. This from the lower class, it's not a new thing, new topic for you. Reflex arc and reflex action, right? You would have studied from the lower class, like how the reflex action is happening and what exactly mean the reflex. So from this part, you can get one question, the reflex arc or reflex action. So as far as the neural control and coordination, you expect three to four questions you can expect. So from this reflex part, a reflex arc, a reflex action, you can get one particular question. So coming to the skin regions, how it moving to the muscle. So you when a pricking sensation when you touch the hot pan or hot furnace or something. So what is happening? This signals which getting passed to the spinal nerves, and from the spinal nerves this to the ganglion. So first reaches the spinal nerves, then it goes to the spinal ganglion. So spinal ganglion is nothing but the collection of the nerve cords through which the synapse is getting transferred. Then afferent. Afferent, always remember, AFF means going inside. EFF, that's the reason, like in textiles and all, if effluent we call effluence means the wastages கழிவுகள் வந்து வெளியில வரதுதான் நம்ம என்ன சொல்லுவோம் effluent. So there EFF always denotes something which is coming out. நம்ம கிட்னில படிக்கும்போது நெஃப்ரான்ஸ்ல கூட afferent arteriole efferent arteriole படிச்சுப்போம். AFF அப்படினா which is going inside. EFF அப்படினும் போது which is coming outside. Okay, going in is AFF, coming out is la EFF. So when the signals passing through the afferent, It's going to the spinal cord region, the dorsal part, and here you could see the interneuron. From the interneuron, and we have it comes to the actual the gray. You have studied about the gray matter and white matter, where the butterfly like edge-shaped structure that you could see as per spinal cord. So this is not actually new thing for you. You already studied in the lower classes, so we're not spending much of time in this case. It's going through the interneuron and coming throughout the efferent, and from the efferent neuron you can sense actually the signals actually. Can you tell me, like, for one reflex action, what is the time duration it takes? If you're touching the out fairness immediately, right, you getting like immediate sensation. Can you tell me like velocity, the speed, or what is the time duration for each reflex action or the reflex arcs takes place in your body? Fine. So coming to the this the last slide which represented the reflex arc. So skin, spinal nerve, afferent, and again it's coming through the interneuron and efferent, and it reaching your muscle so that you can sense the particular thing. Ganglion is actually the fusion of the nerve cords which get fused in particular nerve cords which get fused in particular area where the synapse is getting exchanged. So this is called as gang, ganglia. Okay, the fusion of the nerve cords and nerve fibers. This clumps that you could see is called as ganglia. And coming to the next part, the spinal cord itself. I check. Here you could see the spinal cord. This again tells you like how the reflex action takes place. Coming to this part, it's the gray matter and the white matter. So inside you could see the gray matter. In spinal cord, the inner part you could see is actually the gray matter. This H-shaped structure, right? H-shape, a butterfly-shaped structure that you could see is a gray matter, and outside is a white matter. But you go to the brain, it's in vice versa. You does see the matter like gray matter and white matter, where inside is like white and outside is gray. But when it comes to the spinal cord, inside it's the gray and outside is a white matter. So gray spinal cord, outside it's like out it's a white matter. Inner surface, inner side, H-shaped structure, you could see the gray matter. Where you could see the dorsal horn. So the gray matter is the dorsal horn, and the other part, like is actually the white matter, the white horn that you could see. The two horn-like structure that you could see inside, and through which the sensory neuron, the sensory neurons, here the sensory neuron, and here you could see the motor neurons. I hope I categorize three types of neurons when you're talking about, right? The nerves, where the sensory neuron, motor neuron, mixed neuron. And also I told you like what is the function of like sensory neuron, how the motor neuron function, how the mixed neuron functions. Okay, one is from sensory organs to central nervous system, others from central nervous system to the sensory organ. Mixed neurons, you could see the combination of both. The both is second. So 0.25 seconds that reflex takes place. That's correct. Yes, it's correct. So the gray matter, white matter, and the dorsal root, and here see the ventral node, and this is the spinal nerve. So this is the cross section of the spinal cord. This is not a new diagram for you. So this you're studying from the lower class, right? Even by the 6th grade. So this tells you like, but you need to understand where the sensory neuron and where the motor neuron, and where the sensory neuron soma and the spinal cords, and how they actually the impulses is getting transferred, and how the reflex action. So why I'm showing this image for you, so just to understand the reflex action. In the last slide we discussed about the reflex arc. So reflex action, reflex arc, you can get a questions like identify the incorrect statement, or sometimes they ask you to identify the sequence how the reflex action or the reflex arc is getting passed. They start with the efferent, and they started with the segments, or they mean the phases of the reflex action, and eventually close with the efferent. So you need to understand the phases which involve the reflex action. You need to by heart everything. Just understand what are the stages involved in the reflex action, so the reflex arc can be achieved. For that only I'm showing this particular image. We move to the next part, the sense organ. So almost we're done with the nervous system. Almost we're done with the central nervous system, that is brain and the spinal cord. We're done with the peripheral nervous system. In peripheral nervous system, we discussed about what we discussed, the cranial nerves and spinal nerves, and the formula we discussed. And autonomous nervous system, we discussed about the sympathetic nerves and the parasympathetic nerves actually. So we done the difference, anatomical difference between sympathetic and parasympathetic. You said what is a cauda equina? Cauda equina, after the coccygeal parts, after the tapering end of the spinal cord, you could see like branch-like appearance that you could see. So this branch-like appearance, we call it as cauda equina. So I hope you can recollect. See this case like cauda equina. In cauda equina, where this getting over actually the tapering part. This tapering part is called a spinum terminal. After that, you could see the emergence of the spinal nerves actually like a hair-like thing which resembles like a horse tail. right? This name that because it resembles like a horse tail, where there's emergence of the spinal nerves which comes after the phylum terminal, right? This part is called as cauda equina. Yeah, it's a bundle of spinal nerves and spinal nerve rootlets which resembles like horse tail. It's not blindly don't tell like it's a horse tail. It's nothing. It's a horse tail like appearance. Why? Because of the spinal nerves. Okay, so since it resembles like a horse tail, we name it as a cauda equina. You're correct. Yes. Okay, we move on to the sense organs. Under sense organ, we discuss about few eye. We discuss about eye, and we discussed about ear. And before going to the eye and ear, I explain about what are the other sense organs, common sense organs that you could see. So once we're done, we'll close. Okay. Coming to our sense organs. Sense organs. Okay. Coming to sense organs, we are discussing about receptors. So we'll discuss about receptors. There are three important types of receptors that we're going to discuss. The first receptor is external receptors. External receptor. And the second one that you could see is proprioceptors. Proprioceptor. And third type of receptor is enteroreceptor. Enteroreceptor. So external receptor, proprioceptor, interno. So I'm sorry, this is not interneo receptor. So this all actually we classify the receptors, and these receptors commonly present in the sense organs. Commonly present in the sense organs. Coming to the first type of external receptors, I just tell you like the name of the receptors. You easily find out what is the function of these receptors. Actually, this actually which detects the external stimuli. What is the main function which detects the external stimuli? This is the main function of the external receptors. Coming to the external receptors, phonoreceptors. Phonoreceptors, photoreceptor, gustatoreceptor, gustatoreceptors, olfactory or olfactoreceptors, tangoreceptor, georeceptors, electroreceptors. At last, we have a rheoreceptors. We have one more receptor called as rheoreceptors. It's very common. The receptors. You're going to give an example now. You're going to give an example. So why? Because this type of receptors is not in your NCERT book. Because you would have seen like few previous question papers like they ask even the questions from this receptors. So that is the reason why additional these things are not in the text. I mean the textbook NCERT books, but I'm giving like extra information for you. So if any questions come from the receptors, right, that time you need not blink. So for that one I'm giving all this information. I'm not teaching anything in detail about the receptors. I'm just going to give the receptors and the examples now. Fine. As far as phonoreceptors, it's present in your here. How about photoreceptors? It's a photo means eye. Gustatoreceptors. This is very common. Like when we're talking about the tongue, I told you about this type of receptors. It's present in your tongue. Olfactory receptors. Olfactory receptor. It's for your smell, identification of a smell. Tango receptors. Pain and touch. Tango is for pain, touch, and sometimes like pressure. This can even identify your pressure. So pain, touch, and pressure. Geo. What is meant by geo? Geo is for your gravity. So the gravitational pressure. So the gravity and electropressure. Electropressure is quite common in case of fishes. You could see commonly in case of fishes. Rheoreceptors. Rheoreceptors is for the water current. This is for your water current. Water current. Rheoreceptors is for your water current. So this is also common in case of like water current. Those animals like which lives in the water, especially in case of fishes. Where fishes, you could see the fishes always like groups that you could see, school of fishes which could see we move here and there in the ocean. But you ever seen like the fishes bang with each other because water currents like how the fishes can able to manage the dissolved oxygen. That's one thing. The other thing is the pressure, the water pressure, how it is getting managing, how why the fishes are not banging with each other. The school of fishes moving from one place to other, because the fishes especially carrying this type of receptors called as rheoreceptors. This can easily make help the fishes to identify the water current. So this is quite common in case of aquatic animals, especially in case of fishes, Colidion, right? This type of fishes in the nostrils part where you could see the mouth region where you could see this type of a small receptors. So electroreceptors. Electroreceptors you could see in case of fishes. Even the fishes, the wave currents that you can, how the wave currents like fishes can able to identify. This electroreceptors in case of fishes. Georeceptors is for gravity. But electroreceptors and rheoreceptors quietly common in case of fishes or in aquatic organisms, especially in fishes that you could see. Coming to the proprioreceptors. Proprioreceptors where you could see in tendons and ligaments. Proprioreceptors common, it's quite common in case of ligament. The ligament region, you could see this type of the ligament here and all these places where you could see the presence of how do you sense actually the pain, the ligament here and all. This because of this receptors called as proprioreceptors. These ligaments are you could see in case of tendons. Tendon, you know what is a tendon, right? So in tendons and ligaments you could see the presence of proprioreceptors. Enteroreceptors. Enteroreceptors are statoreceptors, baroreceptors. Enteroreceptor, stato, baroreceptor, and we have the visceroreceptors. So stato, baroreceptors, and the visceroreceptors. Statoreceptors actually the posture. So how your body posture is maintaining. This is because of this receptors. This maintains your equilibrium and your posture, how you're standing erect, so this maintains the posture of your body. This is because of stato pressure. Baro, the word tells you like baro is for pressure, especially when you go with the blood pressure. So BP, the blood pressure, this baro receptors and visceroreceptors. Visceroreceptors occur mostly in case of internal organs. Internal organs. How you experience actually the internal organs? Sometimes you have a pain near your stomach, your pain near your abdomen. Somewhere you sense a kind of pain inside. That is a visceral organ, right? I'm not talking about external. I'm talking about internal. How you can experience this type of pain? This is because of the visceroreceptor. So altogether, the receptors of the sense organs classified into external receptors, which detects the external stimuli. This detects the internal stimuli. Internal is for the internal stimuli. Okay, and we have the proprioreceptors. If any type of questions, if a question comes from any type of receptors, then you can easily identify what is this for. Explain about sensitive to the internal stimuli. So sensitive to internal stimuli, this occurs by means of parasympathetic nerves. So where usually this occurs internal stimuli you ask for, it's because of the interoreceptors. That is like by means of parasympathetic nerves. Parasympathetic nerves, where the internal lining, you could see the internal neural canal, where you could see the neural canal being lined with a specific receptors of mucosal areas. So this able to, you have studied about the malt and all the tissues even which carries this type of signals, and it will be substantially transferring the signals, the synapses to the particular area. There only you would experience the pain. This is not like external receptors. Internal receptors, you have specific receptors being lined the electroreceptors. So we talk about electroreceptors. Electroreceptors is quite common in case of fishes. I told it's not in case of like the human beings. Like it's quite common in the fishes that you could see electroreceptors. And there in electroreceptors, where I told you the electric synapses, where the synaptic cleft, you see chemical synapse and the electrical synapse that I told you, the cleft, the synaptic cleft between your axon and the dendrite is very, very less. It's 0.2 nanometer, where the impulse will be like very faster it will be generated. So there you could see the electroreceptors takes place, where compared to 10 to 20 nanometers for the chemical receptor. So that information you could try to replace in case of electroreceptor, because it's just moving much faster. Why it's much faster? Because the cleft, the gap between the axon and the dendrite of the neuron is less. Okay. So this about the sense organ. So what are the types of reflex? So what are the types of receptors that you could see in case of dogs and fishes, especially dogs? It easily can identify the thermoreceptors, eat and all those things. It can, because in the police, the cops is often they bring the dogs for investigation and all other purposes. They can smell it and they can easily identify the thermo conditions, right? The heat fluctuating conditions. Can you tell me what is a specific type of receptors that you could see in dogs? Dogs are very good in smelling and other things, right? So is there any particular, the part that you could see which play a very important role in case of dogs? which is responsible for this kind of receptors in case of dogs. Respond to stimuli arising within the body, but body such as chemical stimuli, deep pressure, and many others. So of course, you're talking about like the body, such as like chemical stimuli. So when you talk about the stimuli within the body usually that occurs by means of these receptors, like statoreceptors, baroreceptor. That's what I told you. The internal organs where you could see the receptors usually of this kinds like statopressure receptors, baroreceptors, and the visceroreceptor. These three types of receptors that you could see in case of internal organ, that is the visceral organs. So it detects internal stimuli. They internal receptors for the internal. These type of receptors. When we go to the external only, where I talk about the different types of receptors. So when your question is about like you ask about like receptors, how the internal visceral organs, how the pain, how the you would have seen like peristaltic movement. You've seen like how the bolus like it's moving, how the chyme is getting like transfigured, moving from one place to another. This is all again the coordination of the nerves actually. So even though peristaltic movement, we're talking about your cranial nerves, the spinal nerves by means of sympathetic and parasympathetic nerves, which all are getting coordinated. So if this coordinate affects only, which makes the internal organs, like if I'm moving ahead like this, and when I'm smiling all of a sudden, then the facial expression I shows like this all again like coordination effects again by means of these receptors only. So this because of the statoreceptors, baroreceptors, and the visceroreceptors. Especially in fish that contain sensory cells capable of detecting air. So a vertebrate organ found in especially in fish, the scolidian and all the species you could see, it's a specialized function that you could see where you could see this type of special receptors because it's based on again the adaptation. So when you talk about this particular organisms getting adapted in particular area, these organs how it's slowly slow and steady start getting adapted. Then these receptors, you can ask me those receptors which present right from the birth. No, sometimes what happens when you start adapting with a new area, new environment, then what happens? This receptors start emerging, right? Then what happens automatically? This receptors which makes you to adjust with a particular environment or to withstand with a particular environment. So your central nervous system along with this like autonomous and peripheral nervous system, which gives a way for the person or particular organism to adapt to the environment, either like internal or the external conditions. So it may even like substantially reduce the receptor or may substantially increase the amount of receptors so that the organism can be able to adapt to the particular environment correctly. Okay. Okay. So we're done with the sense organs, external, proprio, and the internal receptors. In case of like you could see the dogs and fishes, you have thermoreceptors. It is called as ampullae of Lorenzini. We call it as ampulla of Lorenzini. So sometimes they'll ask ampulla of Lorenzini, which place that you could see this is quite common. You could see in case of fishes and dogs. This ampulla of Lorenzini is usually for a dermo how it can identify the fluctuations of the temperature. This ampulla of Lorenzini usually you could see in case of fishes and the dogs. If any question comes, ampulla of Lorenzini, which this is for dermo control. So this is for the dermo receptor. This is thermoreceptors. It's quite common in fishes as well as in dogs. Fine. So type of reflexes you take, we have the spinal reflex, we have the cerebral reflex. Two types of reflex, commonly we call it as spinal reflex, other one is a cerebral reflex. And we have the mono reflex and we have a polysynaptic reflex, or sometimes we call the reflex as a simple reflex, or we can call it as an acquired reflex. Certain reflex which is present right from the birth actually. Okay, but certain reflexes which is getting acquired when you start growing, the child start growing, certain reflex mechanisms started acquiring, right? So this acquiring mechanism is called as how the reflex started acquiring when you start growing. This is called as acquired reflexes. So this is quite common, the classification of reflex mechanism that we call it as. Now we move to the sense organs. First we'll start with the human ear. Human ear, and then we move on to the human eye. Coming to the human ear. Yes. You could see the structure, the anatomy of the human ear. So as the ear, it classified into the outer ear, the middle ear, and the inner ear. So outer ear, middle ear, and inner ear. As far as outer ear is concerned, the outer ear is actually which that you could see outside from outside is a pinna. You could see the pinna, the outermost area that you could see is a pinna and your auditory canal, and you could see the eardrum. So, and the function is like funnel and conducts the sound to the middle ear. This is what actual function of the external ear, that is like pinna, that the external surface that you could see. And followed by the pinna, you have the canal. This canal is called as auditory canal. And this auditory canal which leads to the drum like structure. This drum is called eardrum. So this is tympanic membrane. So tympanic membrane. So I'm not explaining about the ear in detail because just your reference I'm giving. So tympanic membrane is actually the eardrum where you could see. And after this eardrum, you could see the middle ear, the ossicles that you could see. The ossicles are what are the three ossicles? We have malleus, incus, and stapes actually. So malleus, incus, and stapes. This constitutes the middle ear. Three bones in each ear, like you have three ossicles here, and the other ear you could see the three ossicles. So malleus, incus, and these stapes, and followed with the middle ear, we have again you could see the oval window, and this eardrum connected with the middle ear, and then we have the oval window. And the oval window, which consists of inner ears, which consists of semicircular canal, and we have a cochlea. These two constitute the structure called as vestibular structure. We have the vestibule inside. And coming to the vestibule, then we have connective tube. This is called as eustachian tube. This is eustachian tube. This eustachian tube which are directly opening into the nasopharynx. So that's the reason when you put any drops inside your, like your ears also, you can feel it in the nose, like whatever you're doing in the nose, even like mouth, your eyes, your sorry, your ear, your nose, your mouth, like these all are interconnected. So because eustachian tubes are connected with the nasopharynx, and we have the round window. So this is the structure of the ear, anatomy of the ear. Coming to the ossicles, ossicle part of the ear, I tell you like three ossicles which present. These are malleus, incus, and stapes. Coming to this part, so this is a malleus. Malleus, the first ossicle, and this is our incus. So this is structure of the incus, and we have the stapes. Actually, this is connected with the oval window. So this is a base. This is actually very soft and short bone that you can see the stapes, and this is the structure of the malleus. So these one malleus, two incus, and the third one is a stapes. Actually, these two are connected, and this we call it as an ear ossicles. This we call it as an ear ossicles, which are actually three pairs in number, left as well as in a right ear is concerned. Okay, so need not worry about other parts. Just like how the malleus, incus, and stapes look like. For that only, just giving this direct image for you. Coming to the internal ear. Coming to the internal ear, we have semicircular duct. Important regions of the internal ear, we have semicircular duct, and the semicircular duct, which consists of two parts. One is a bony labyrinth part that you could see. Other one is like membranous. One is bony part. Other one is membranous. The purple one which shows actually the bony, and the blue color which shows the membranous labyrinth. When you see the circular ducts, we have anterior, lateral, and the posterior part, and this getting connected with the circular structure. This is called as cochlea. This is the main part that you could see, the cochlear region. This cochlea consists of vestibular duct, we have cochlear duct, and we have the three ducts that you could see in the cochlear region. What are three ducts that you could see? Is actually vestibular duct, cochlear duct, and the tympanic duct. Together, this constitute, we call it as an internal ear. So, as far as internal ear is concerned, semicircular duct, and we're talking about the cochlea. In cochlea, there are three ducts are present: vestibular duct, cochlear duct, and the tympanic duct. So, this is about the internal ear. When you just go even deep inside, like how the lateral section of this, the inner ear will look like. And you could see something like semi canals. If you could see this canals, we call it a semicircular canal. This I'm talking about the internal ear. I'm talking about the internal ear. You could see the semicircular canal, and the anterior and the lateral, the posterior canals that you could see. And then we have the ampulla of the semicircular canal, and this has been connected to the cochlea. So this nerves, which is connected with the cochlea, this is your auditory nerve. And here also you could see one ganglion, right? The name of the ganglion is Scarpa's ganglion. The name of the ganglion is called as Scarpa's ganglion. Clear? So, coming to the innermost, like organ of Corti, the scala vestibuli, scala tympani that we're talking about. So when we're talking about the organ of Corti, the overall cross section, the internal structure that you could see, we have three important regions. One is scala vestibuli, we have scala media, and we have scala tympani. So we have three layers, and this we deals with something about the mechanism of hearing. So mechanism of hearing. When we discuss about mechanism, we have air-like structures which you could see inside actually. Here in this part, the organ of Corti in this part, you could see the air-like structure. When the articulation takes place, the sound, the vibration when reaches the air follicles which present inside the organ of Corti, which bends like this actually. This which makes actually which help you to identify what exactly the sound. Can you tell me like what is actually the decibel? How much of decibel your ear can take? So what is the the amount of the decibel? So we have the decibel, the measures that you can. This is actually the amount of sound your ears can accommodate. A maximum of what is the decibel your ear can take, beyond which this decibel, if it goes only, this affects your eardrum. It means it affects your organ of Corti as well. So what is the maximum, the capacity, the amount of decibel the human ear can accommodate? Can someone tell me what is the decibel that human ear can accommodate? So scala vestibuli, scala media, and here we have the scala tympani. This been connected, organ of Corti been connected with the cochlea. So this is where the cochlea which comes, and this cochlea which comes here, and this cochlea been connected with the cochlear nerve fiber. Because the previous slide I told you like the cochlea connected with the nerve fibers. These nerve fibers which connected with this organ of Corti. This organ of Corti will consist of like air nerve cells. You could see the air nerve cells. Here you could see the air-like structure. This air-like structure which moves actually depends upon the vibration of the waves, like what happens, the air cells which moves, and based on that only the signals which move onto the basilar membrane, and then the sound can be identified. So this is what the organ of Corti look like. Fine. Now we move to the mechanism of hearing. So when you talk about the mechanism of hearing. Mechanism of hearing. So very simple ways I mentioned approach at mechanism of hearing. So how you could hear a sound and how the sound is actually reaching your internal ear actually. So the first will start with the external ear. The external ear which receives the sound waves, which receive sound wave. So what happens to the sound wave? The sound waves which reach the eardrum. Now you just make the sequence around, that's all. So you make the sequence, the mechanism of hearing. Your sound waves, this goes to the eardrum, and this goes to what's the next part? This goes to the tympanic membrane. This goes to the next area called as tympanic membrane. So the diagram itself has shown like how the tympanic membrane look like. So it reaches the tympanic membrane, and then it causes a vibration. And this tympanic membrane, this vibration, which reaches to the next part, that is your ossicles. There are three pairs of ossicles, like ossicles, and these ossicles which move on to the oval window. Then the vibration which moves to the oval window. From the oval window, it goes to the perilymph of scala vestibule. It reaches the perilymph of scala vestibule. I told you like scala vestibuli, tympanic membrane, venous membrane. So this reaches the perilymph of scala vestibuli, and then it reaches the vibrations reaches to the scala media. It reaches the vibrations reach to the next region is called the scala media, right? And coming to the scala media, this goes to the basilar membrane. Basilar membrane. It goes to the basilar membrane. From the basilar membrane, there's a place where like the hair which starts bending actually, the air cells will start bending, and this cells which gives the pressing them against the tectorial membrane. So air cells which press against this press against tectorial membrane. This press the tectorial membrane. This air cells which press the tectorial membrane, and then from here this is the place what happens like nerve impulse generator. This is the place the nerve impulse generator. So once the nerve impulses started generated, then what happens, this goes to the auditory nerves, and then this goes to the auditory nerve, and then impulse has got analyzed here. Impulse has got what type of sound whether it is noisy, whether like what type of exactly the sound like. So this is all the entire mechanism. This part you get the sequence actually. So for that one, I'm just giving the flow chart. So first the external ear receives a sound wave. This goes to the eardrum. Next comes the tympanic membrane. Then it goes to the ear ossicles. It goes to the malleus, incus, and stapes. The pairs of like ossicles. It goes to the oval window. It goes to perilymph of scala vestibuli. That is in the region that includes organ of Corti. Then scala media. Then goes to the basilar membrane. Then where you could see the air cells which press against the tectorial membrane, and then the nerve impulse was got generated. The question comes even like this way: from which part is responsible for the generation of the nerve impulse? Then the tectorial membrane. They given the different membrane, Raynaud's membrane, different types of basilar membrane. So tectorial membrane. Tectorial membrane is the part where you could see the nerve pressure is getting generated. This is because of what the air cells which is getting slightly start bending by means of the vibration. So the tectorial membrane started generating this nerve impulse. It goes to the auditory nerves, and then at last the impulse getting analyzed here. So impulse is getting analyzed, and finally sound. So what type of sound? It's a very louder or like melody, or what type of sound that is getting recognized. Ossicles means the three bones that we are talking about, like malleus, incus, and stapes. These three are called as ossicles. So malleus, incus, and stapes. These three bones, actually the ear bones we're talking about, right? These ear bones we call it as ossicles. There are six in number, right? And oval window, like oval window is a structure. I've shown the last the video clipping. It's like oval window. Usually it'll be like this actually. The oval window, like through which what happens, the ear ossicles are being connected actually. So this is the oval window. So vibrations comes to the oval window, and through this like ossicles, this vibration is moving to the organ of cortex. The window like appearance that you could see. This is called as uh, oval window. And can someone tell me what is actually the pressure? So I've given the decibels. What is about the pressure? So how much of pressure your ears can take up? Is there any particular like the pressure you because we are barotolerant, right? Beyond this particular pressure, like ears may not take take beyond that particular pressure. Your ears cannot. What is actually like the range of pressure? Usually your ear, the membranes which present the ear ossicles, mainly your cochlea. Your cochlea can able to adjust that. So what is the range of the pressure your ear ossicles can take up with? Can someone give me the answer? If you not, I can tell you the answer. Fine. This is about the mechanism of hearing. Okay, we move on to the next part. The next part is human disorders, actually disorders of ear. When we talk about the disorders of ear, can someone tell me what are the disorders of ear? Talking about the disorders of ear, it is like first we talking about otitis media. Otitis media. Second, the disorder is Meniere's disease. What do you mean by the Meniere's disease? Usually it affects the Meniere's disease. Meniere's disease. Third one, Eustachitis. Eustachitis. It means the inflammation. I told you like any word ends with the suffix itis is actually inflammation of eustachian, the particular area. So here Eustachitis means inflammation of the eustachian tube. Okay. So you're told like Desa kappa spells like 50 to here. It is like a range of like plus 50 to minus 200. Yeah, that is correct. Plus 50 to minus 200. Yeah, you're correct. So Eustachitis. Then we have ostalgia. Ostalgia. These are all like ear-related disorders. Meningitis. All right, meningitis. Then vertigo. Vertigo. So these are some of the disorders of hear. Okay. What is otitis media? Again, otitis media is itis. It stands for the inflammation. Otitis media is inflammation of what is the meaning of otitis media? Which part of the ear? Whether it is a external ear, a middle ear, or inner ear. So which specific area we're talking about? The inflammation of which part? External ear, middle ear, or internal ear? Then venous disease. Venous disease where you could see reduction in the fluid actually in the ear. Reduction in the fluid in the ear. This condition is called as Meniere's disease. The perilymphatic fluid. The perilymphatic fluid levels start reducing then automatically what will happen? The lubrication and this vibrations may not be passing properly inside. So this is called as venous disease. Ustatitis is actually inflammation of eustachian tube. What is ostalgia? Ostalgia is a common thing, but we usually call it as a ear pain. The sort of ear pain, usually we call it as ostalgia. Ostalgia is a ear pain. Meningitis, inflammation of the tympanic membrane. Inflammation of tympanic membrane is called meningitis. Vertigo is actually kind of dizziness. If I tell something more precisely about vertigo, is the person experience a kind of motion, even though the person is standing and sitting in a particular place in a stationary mode. The person can, if he or she feel like kind of motion, always something is moving inside and out, like this kind of motion experienced by the person, even though they are in stationary mode. This is called as vertigo. This is actually dizziness, where a feeling of like motion is experienced if the person is actually in the stationary mode. If he is in the stationary mode, she is experiencing a kind of motion. This is called a kind of dizziness he or she can experience. This is called as dizziness. I mean vertigo condition. So normal ear pain we call it as ostalgia. Inflammation of the tympanic membrane is called as, so you can say rupture of the ear drum. Rupture of the eardrum is called as meningitis. That is like tympanic membrane. The tympanic membrane is getting ruptured. It's actually meningitis. So the fifth one is meningitis. MYR. This is RI. Meningitis is the inflammation of the tympanic membrane. Otitis media. Otitis media related to which part? External ear, middle ear, or the internal ear? Which part of the ear usually we call it as meningitis? External, middle, or internal ear? Which part we related with the otitis media? So these are the common disorders we're talking about the here. Okay. Otitis media is normal the inflammation. So that's why I raised the question. So I give an explanation for all the remaining disorders. Otitis media is quite common. Which part of the ear usually get affects? The middle ear. The middle ear usually which gets affects the inflammation of the middle ear, right? This inflammation of the middle ear, maybe because of some microorganisms or secondary infections, maybe this also this otitis media may be caused actually. Sometimes people they have the the thing of practice of using what is it called earbuds. So they use a earbuds. Sometimes they have the wax is also quite good. Sometimes what we'll do is actually the wax is getting keep on accumulating. We try to take the wax is good, but what we do is we apply the eardrum or some other things. We just poke inside your ear and try to remove it. So by means of any bacterial infection, also the inflammation can occur in the eardrum. So in the middle ear. So this is called as otitis media. Third disorder is actually eustachitis. So eustachitis is inflammation of the eustachian tube. Inflammation of eustachian tube. This tube is getting inflamed. So I hope you can recollect eustachian tube, tympanic membrane, where these regions are present. But that only I just gave the first. The thing is, so this is what actually called it as eustachian tube. This is where the eustachian tube is present. For that reason only I told shown the first diagram the beginning itself. This is the eustachian tube. So this is a tympanic membrane. Here you could see the tympanic membrane. Here you could see otitis media, where you could see the auditory canal here, where you could see the inflammation which occurs in this particular region also. This main leads to the otitis media. And you asked about ossicles. These are ossicles. So we call it as here ossicles. We have malleus, incus, and stapes. And this is what oval window. Someone asked about the oval window. So what exactly the oval window look like? So for that one, I've shown the oval window. Here you could see the window kind of the appearance, right? This region is specifically called it as a oval window-like structure, where the ossicles are getting connected with the inner ear. So the ossicles, the middle ear, the three ossicles are getting connected with the oval window by means of the inner ear, by means of this oval window. So this tells like eustachitis is actually inflammation. Eustachitis. This is the inflammation of this particular tube is getting inflamed, right? This condition is called as eustatitis. And sometimes the eustachian tube may also get inflamed if the person is having a problem with the nose, nasopharyngitis, right? Any issues with related to the nose also, because it's a common connectivity, because eustachian is connected with the nasal part. The person's having some issues with the nose also, then what happened? This particular tube, which act like a bridge, may also get chance of getting inflamed. Inhalation, like inhalation of some pollens, inhalation of dust, danders. This may be reasons where the station tube getting inflamed. Okay, so eardrum. Eardrum is nothing but the tympanic membrane. So inflammation of this tympanic membrane. Inflammation of the tympanic membrane, we call it as. So I told you like in the last, inflammation of the tympanic membrane. So inflammation of the tympanic membrane. So meningitis. I told you like meningitis. Meningitis, inflammation of tympanic membrane. It means what? It is a eardrum. Eardrum is otherwise called as tympanic membrane. So inflammation of the tympanic membrane. Inflammation of the tympanic membrane. This condition is called as meningitis. Meningitis. So you say that times pressure is high as 20 times pressure is high. So it need to accustomed or adjusted inside. For that only we have it's passing through the station tube. We have different channels where pressure is bifurcated and it's getting substantially reduced, so that this is getting adjusted when it reaching the ossicles, right? That time itself, how much ever the pressure is coming from outside, the atmospheric pressure is bearing actually. When it reaching your ear, what happens? Substantially your pressure is getting regulated, because when it is crossing all the way right from the pinna to the external through the middle ear itself, your pressure is substantially is getting adjusted and accustomed to your internal ear. So there won't be much of variation. This oval window, all these things which takes a corrective measure so that it can adjust the pressure. If this part is not performing its functions, the deficiency in the oval window or the ossicles, if there is some issues with this part, then definitely the pressure will be greatly increasing. Then it affects the cochlea. If cochlea is getting affected, then your organ of corti, the scala vestibuli, that other reasonous membrane, baseless membrane, it loses its function. Then it leads to a permanent condition is called as where the person cannot hear properly. Okay, fine. So, okay. So we done with ear part and the ear disorder. Fine. Next we move to the ear, height. So we'll start with the human height. So this again like a very common thing that we have been studying right from the structure of height. So when we talk about the height, the structure, so I don't think like much of information is required, but as far as the structure of our eye, because the eye is concerned, because we've been studying right from the lower classes. We have iris here, the cornea. We have cornea, pupil, lens, conjunctiva. So this is a place where any inflammation occurs in this conjunctiva. We call it as conjunctivitis. So conjunctiva, we call it as a Madras eye, right? So this is not like Madras eye, Bombay eye. We have this condition is called as inflammation. Conjunctivitis. Conjunctivitis is the inflammation, and iris, cornea, and the humor. Here, the space that you could see, right? The space is called as aqueous humor. And here in this part, this is called as vitreous humor. This region, right? This is called as vitreous humor. This is the gap that you could see from here, from the ciliary body to the retinal cord. This is called as vitreous humor. And in the front region, the anterior part, the anterior chamber, you could see, right? This is called as aqueous. There are two humor which is present. So one is aqueous humor, the other one is vitreous humor. Vitreous humor is actually the posterior part that you could see, after this ciliary body which connects to the retinal part. In the front part where you could see the aqueous humor. So that you could see two humor. Can someone tell me like which organisms cause conjunctivitis? Maybe the virus or bacteria. Which organisms usually which cause conjunctivitis? When we make humming sounds, we're doing this sound. It's again like the pharynx, and that is actually like sound which how you snore, when you snore, and when you make snoring and all these things. How this is happening like because of the nasopharynx actually, when the abnormality, when you could see from the tracheal part, from the voice box itself, when it just this a voice which comes like the sound which all comes because of not only from your mouth, it's also related with the nasopharynx, which this comes from the voice box itself. We makes the mimicry and all the sounds which comes is related with the pharynx, laryngopharyngeal region. That is the larynx and the pharyngeal part combined together. You could see this type of alteration of sound, and also this comes from by articulation of your, what is it called, your tongue as well. This articulation this comes. So and comes for the codes. We have two codes: sclera code, choroid code, and the retina. We have three codes. The outermost code of a eye is called as scleroid. The middle part is called as choroid, And the inner part of your eye, the layer is called, these are the three layers that you could see as far as eye is concerned. This is outer, this one is middle layer, and retina is the inner layer. And we have region called as blind spot. You could see the blind spot here. What does a blind spot mean? So what is a blind spot? Is there any specific function or is there any specific term that you can give for a blind spot? What is not exactly present in a blind spot? Can someone tell me what is this, the blind spot is for? And here you could see the optical nerve. So this diagrammatic representation which tells you like how the eye part exactly look like. So as far as human eyes are concerned, you can expect a question from the pigments part only. So when you come into the pigment region, so what are the main two pigments which is actually produced by the eye? We have two types of pigments actually, two types of cells even I can call it as rods and cone cells. We have the rods and cone cells. Coming to the rods and their cones. So as far rods are concerned, this produce a pigment. What is the name of the pigment? Which usually we call it as visual purple. What is the actual name, the scientific name that we give for a visual purple? What is the name of the pigment the rod cells are producing? So it's usually called as visual purple. And this visual purple, this pigment is responsible for what? This is for your dim light. This gives the perceptions for your dim light. Also, you could see the things actually, right? So this can able to identify the objects even in your dim light. Cone. As far as cone cells are concerned, this produces a pigment actually called it as erythropsin. This produces a pigment called as erythropsin. Erythropsin is actually the pigment which produced by this cone cells. Erythropsin, along with erythropsin, iodopsin and cyanopsin. Iodopsin and cyanopsin. These are the pigments which produced by the cone cells, and this pigments are responsible for your daylight, the bright light. You can able to visualize things. We can see things clearly. So cones is for daylight and rods is for a dim light. So the name of the pigment is rhodopsin. So from this area only, often you get a question from the pigments region only. You get a question as far as eye is concerned. You get a questions from this part. So rhodopsin is produced by the rod cells, and cones is produce the pigments called as erythropsin, iodopsin part, and the cyanopsin part. Cones are responsible for daylight, and rhodopsin is for preserving the image in the dim light. Okay. And what do you mean by yellow pink spot? We have a yellow pink spot. Where this yellow spot is present in your eye? Yellow spot. Where this yellow spot is present, and the region where the yellow spot is present is called as macula lutea. So this region is called as macula lutea. So can you see this region? The macula. This region actually we could see the yellow spot. The yellow spot is present in the macula lutea. And the blind spot, I asked something about the blind spot. What is not exactly present blind spot? So it's caused the blind spot and which is not inside the retina. So where the retina, that is not the place where not the region which is exposed to the rhodopsin or like any other pigments actually. Okay, that is a region where it's not the part of the retina. So that is a region where the blind spot. And yellow spot is present this region. This region is called as yellow spot. This yellow spot is present in a specific part called as macula lutea. And we have some central pit. This pit is called as fovea centralis. We have a pit here, and this pit is called as fovea centralis. This is called as fovea centralis. So the macula lutea, which has got some pit-like thing, that is indeed we call it as a yellow spot. And this yellow spot, the pit-like small pit that you could see in this macula region, that pit is called as fovea centralis. So when you talk about the spots, we have discussed two spots. One is a blind spot. Here, the blind spot. The other one is the yellow spot. The yellow spot is present in the macula region, and where you could see the pit-like formation, and this pit is called as fovea centralis. Fovea. This, the terminology that you should remember when you talk about the spots here. Okay, we're done with the eye, and coming to the mechanisms. When you talk about the mechanism of eye, so how actually you can visualize things actually. Mechanism of vision. First, the light hits the rod cell. I told you which is the rod cell, the rhodopsin. The rhodopsin rhodopsin, we could see the which isomerizes the retinal part, and rhodopsin converts. So what is happening in the rhodopsin? So once the light hits the rhodopsin, which converts to meta-rhodopsin, it is getting converted to meta-rhodopsin, and this meta-rhodopsin 2, right? This meta-rhodopsin 2 is getting converted. It's activating transducin, which activating transducin, and transducin activates phosphodiesterase enzyme. So the main enzyme that you could see is a phosphodiesterase that you could see in this case, phosphodiesterase, and the phosphodiesterase which hydrolyzes cyclic GMP. So can someone tell me like what is the cyclic GMP? Cyclic GMP is for GMP expansion text for GMP is for what? GMP, cyclic GMP, and cyclic GMP is gas, and so sodium channels close, and then the sodium channels getting close, what happens? It will become hyperpolarized, and electrical impulses is getting sent to the brain, and through which what happens? Like you can see the image as well. So this tells you like the mechanisms by which you can identify. Okay, opsin is actually a pigment, normal pigment that you could see. Opsin, under the opsin you could see the rhodopsin. So opsin is actually kind of the pigment. Opsin, you can see it's a pigment. So under the opsin you can see the rhodopsin, the pigment which comes. Okay, so we're done with the mechanism of this thing. So opsin, when you talk about opsin is generally what? It's a protein structure. So when we talking about opsin, so what is the main function? Is a covalently bind. It's actually vitamin A residues actually. So opsin is vitamin A. Vitamin A chromophore. It's actually a chromophore, and this is actually you could see like three extracellular, three cytoplasmic loops also present. So basically, opsin is a protein. That's a visual protein. Is a derivative of vitamin A. It's a vitamin A. Okay. So when we again recollect the mechanism behind actually how you can visualize. Okay. Visual purpur. It's not this. Visual purpur is other name that we give for rhodopsin. Rhodopsin is otherwise called as visual purple. Okay, so I think we are done done with the main mechanism, and now someone asked like canal of what is it called? Schlemm. So canal of Schlemm is actually a sclerocorneal junction. Sclerocorneal junction. It's a sclerocorneal junction. So you asked a question. What is a yes, what is it? Schlemm. So canal of Schlemm. So canal of Schlemm is actually the circular canal lying in the substance of sclerocorneal junction. Sclerocorneal junction. So this is actually we call it as Schlemm. Okay, the canal of Schlemm. So this is responsible actually into the main functions we could see in the present aqueous humor and from the anterior chamber into the veins, and it's actually draining of the eyeballs. So sometimes what happens, the eyeballs which get drained sometimes, right? When this getting drained, this because of the canal of Schlemm. This because of canal of Schlemm. So this is for draining of eyeballs. Draining of eyeballs. Okay, so rhodopsin is a pigment actually. In the last slide I told you like rhodopsin and the other pigments that I told you, like rhodopsin, the pigment which you can able to see even with the dim light actually. The dim light that you can see that we discussed. So coming to the eye related disorder. So when we talk about eye related disorder, can you name some eye related disorders? Eye related disorder. Okay. So first main eye related disorder is myopia. What is myopia? Myopia. B is hypermetropia. What is the difference between myopia and hypermetropia? Myopia and hypermetropia. Then common the thing is called as cataract. Cataract. Then so Myopia, hypermetropia, cataract. We have glaucoma. Glaucoma. Then we have astigmatism. Astigmatism. Okay. So coming to myopia, myopia is short-sightedness. So short-sightedness, this condition is called as myopia. Long-sightedness is called as like hypermetropia. Then cataract is actually the fluid, like the cloudy things which covers the front part, like the lens or cornea. This region, this actually called as cataract. This can be even rectified by means of laser surgery. Then glaucoma. Glaucoma increase in, what is a glaucoma? Something is getting increased, right? Increase in interocular pressure. So that is what actually, like glaucoma patients, like usually the doctors, like they won't prefer to go for immediate surgery because the pressure, like an ocular pressure, must be like exact pressure that is required for the surgery. So if the pressure going to intraocular surgery, it's more, then like they'll be waiting for the pressure to substantially to get reduced. So if there is some pressure is getting increased in the eyeballs, like intraocular pressure, this condition is called as glaucoma. Okay, astigmatism. Coming to astigmatism is curvature of the cornea. So this condition is called as curvature of cornea. So curvature of cornea, this is called as astigmatism. So what type of corrective measures, like doctors, I mean the ophthalmologist, optometrist, they prefer in case of myopia or hypermetropia? In case of myopia or hypermetropia, what type of corrective measures? I mean, what type of lens actually the doctors, ophthalmologist prefer? Can someone tell me like what type of lens? Can someone tell me what is the type of the lens the optometrists usually prefer? So you ask like presbyopia. There's one more condition called as presbyopia. Presbyopia is a condition, we call it as night blindness. So night blindness is a condition called as presbyopia. Is actually how it is caused. Actually, this is actually caused by presbyopia, which caused actually what is it called, like elasticity, loss of elasticity. Sometimes which happens like loss of elasticity of the lens. Since loss of elasticity of the lens which occurs, like this leads to condition called as like presbyopia. Myopia is a condition where you could see where the doctors which advise to go for a concave lens. The vice versa condition is called case of hypermetropia, like convex lens that you could see, the bifocal lens that you could convex for presbyopia. Yes, of course. So these are the related things that you can expect, but usually you get questions from this particular area from the eye is usually from what? From the rods and corns cells. That is rhodopsin or like other pigments like corns and rod cells that you can expect. So presbyopia is a convex lens that you can give, and astigmatism is of course like cylindrical. So optometrists prefer in a special type of lens is especially applied for this type of, and surgeries again the cataract surgery, fluid kind of accumulations, like if the, for example, a patient has got like cataract in both the eyes, like how, what type of like preference like the doctors advise to go, whether the doctors perform cataract on both the eyes at the same time, or is there any age related like prescriptions or the surgery measures they will do, or is there any other preferences they will go like as special like intraocular pressure, they check for the intraocular pressure, or they directly go with the laser treatment? Is there any particular preliminary precautions they will take, especially ophthalmologists they concern, like, or they try to like first one high they will go with the cataract laser surgery, and then after the span of like how many months, like they prefer to go with the other, I mean for the next eye, the cataract surgery. So because nowadays it's quite, is there any particular reason for the cataract? So because nowadays the cataract is getting increased, like is there any other reason, not because of like age related disorders, is there any other reason, like there are chance of the patients are getting exposed nowadays with the cataract? So age precautions. One thing is like age precautions when they go beyond like 45, even 50 plus again, right? Nowadays you could see the people's like the small young age children also the chance of getting the cataract actually. Is there any reason? Is there any kind of like mutation? Is there any kind of like radiation which play a very important role? Cataract and diabetes, of course. Like you mentioned diabetes. Which type of diabetes you're talking about? Diabetes like insulin dependent or insulin independent diabetes? Which diabetes? And rays, of course, ultraviolet rays you're talking about, and pollution. The person who are exposed to soot and dust all the time. These chemicals, even the pollutants, also have a chance of getting cataract. And of course, chlorination. Sometimes like chlorine. If the people are going with the wearing a contact lenses most of the time, and if they go with the swimming pool, the chlorine content is again. Is there any particular type of disease? I mean, organisms which even spread through by means of the contact wearing the contact lenses? Can someone tell me what is the name of the organism? Especially if they go for swimming, again there becomes high chlorine content. Again, this organisms can gain entry inside the ocular region. This can even any microorganisms which has the ability to cause eye related disorders. Can someone tell me? Okay, so changes change nature, but usually it affects by means of ultraviolet rays. You would have studied like when you study about the ozone depletion, all these cases you would have studied definitely about the cataract UVB, ultraviolet B rays. This even penetrates inside, not only on your skin. This not only causes skin cancer, but this also give chance of causing more of cataracts. Okay, so these are some eye related disorder. So I think we come to the end of this particular chapter, that is neural control and coordination. So let us have a quick recap of what are the things that we discussed. We started with the nervous system, neural control and coordination, central nervous system, peripheral nervous system, autonomous nervous system, and that sympathetic nerves, parasympathetic nerves, spinal nerves, cranial nerves that we discussed, and also we discussed sense organs, the type of receptors that we discussed, and eventually we done with the human eye and human ear and gustatory receptors, thermoreceptors. From this area, you may sometimes get in some type of question. So by this, we're completing the entire unit called human physiology. Human physiology is getting over by today. Possibly as per your preference, as per the instructions given to me, like the next chapter that we'll be dealing, either we go with the cell biology or for your preference going with the botany or plant physiology. So I have no issues. We discuss or start with the plant physiology, or you can go with the cell, the structures and functions. So I hope you listen to the class, and I really appreciate your time and patience. So please go through, because we're done with all the 7, because majority of the questions that you get from the human physiology. So please be very thorough with all the 7 chapters that we discussed so far under human physiology. So feel free if you have any doubts or any clarifications, and please don't waste your time. So um, microorganisms that, so I ask you some questions again, you're bouncing back that question onto me. So is there any particular organism I asked you like is responsible in causing cataract? So especially those people who have chance of going to the swimming pools. I just given a clue also. So those people who have like practice of going to swimming pools, the contaminated water even has a chance of causing the eye conjunctivitis, like eye related this thing. So thank you for joining with me. Thank you so much. And guys, I hope like you're receiving all the links is related with the question paper discussions. So please go through, click onto the link and go through the question paper discussions. And if you have any doubts in the question paper part, if you need clarifications, please feel free to ask us. So I'm happy to even explain those doubts. Please don't skip those videos that we have updated, especially with the question paper discussions. Thank you so much. Thank you all.